Now let's just do a little bit more practice with that on drawing those structural formulas. So draw the dot structure and name PBr3. All right, so it's easy to start with phosphorus. If we look on the periodic table, it's a group 5 element, which means it's got 1, 2, 3, 4, 5 valence electrons, and it's got 3 places to make bonds. Bromine is a group 7 element. It's a halogen. It's got 7 valence electrons, so it's got 1 place to make a bond. So we can see that this electron can share with any of the singles over here, and we have 3 bromines. So we're actually going to end up with phosphorus with its lone pair of electrons that don't form bonds, and then 3 spots for it that will form bonds. So we get our bromines on all of these. Now remember to draw on all your electrons because we're always going to obey the octet rule. We always want 8 valence electrons, and since bromine has 3 pairs of electrons that won't bond, we have 3 pairs on each bromine, and then we have our single bonds, so 2, 4, 6, 8, and we can do that for every element and see that they all have 8 valence electrons. And this is phosphorus. It's not monophosphorus, it's phosphorus. We don't use mono on the first one, and then the prefix for 3 is tri, so this is phosphorus tribromide. That's how we name it. We change the ending to IDE. The bromine becomes bromide, and the prefix tri means 3 bromines. So phosphorus tribromide. We only use prefixes on molecules. Draw the dot structure for and name CH4. Okay. Carbon has 1, 2, 3, 4 valence electrons. And we said when we looked at ions that carbon will form an ion. It doesn't really want to give up 4 electrons, doesn't really want to take 4 electrons, but it'd be perfectly happy to share 4 electrons. So hydrogen has got 1 bond it can make, carbon's got 4 bonds it can make, and so we have 4 single bonds here, and this is carbon, tetra for 4, and hydrogen becomes hydride. So we basically only keep the first syllable of the second element and change the ending to IDE. A couple more. The dot structure for P2I2. P is phosphorus, and this one's a little bit tricky. Phosphorus has 1, 2, 3, 4, 5 valence electrons. Iodine has 7. 1, 2, 3, 4, 5, 6, 7. That means iodine can only make 1 bond. So we can have a whole chain of atoms in a molecule, but if something can only make 1 bond, it has to be at the end of the chain. And so I'm going to put iodine on one side, and I'm going to go ahead and give it its 3 pairs of electrons. I don't need an end yet because I have a phosphorus. It's got 2 pairs of electrons that can't do anything. I'm going to have another phosphorus. It's got a pair of electrons that can't do anything. And then I'm at the end of my chain with iodine, and it's got its 3 pairs of electrons that don't bond. And then I'm going to count it out. 2, 4, 6, 8 electrons for iodine. 2, 4, 6, 8 electrons for iodine. 2, 4, 6 electrons for phosphorus. If you look at phosphorus, it should be making 1, 2, 3 bonds because it's got 3 unpaired electrons. Well, I can make that bond in the middle a double bond, and now 2, 4, 6, 8 electrons for each phosphorus, and everything obeys the octet rule. This is P2I2, and this would be diphosphorus because there's 2 phosphorus atoms. Diphosphorus diiodide. Okay, that's a funny name, but there it is. So diphosphorus diiodide, 2 phosphorus atoms to 2 iodine atoms. Draw the dot structure for and name SiO2. Silicon looks a lot like carbon. It has 4 valence electrons, so it can make up to 4 bonds. It needs to make 4 bonds. Oxygen can make 2 bonds. It's got 2 unpaired electrons. This is O2, so I'm going to go ahead and say, okay, well, oxygen can make 2 bonds. It'll make those 2 bonds to a silicon atom, which can make 2 more bonds. It'll make those 2 bonds to my last oxygen atom. And now I have 8 valence electrons on everything. And this is silicon. Remember, we don't use mono for the first element. Dioxide. Okay? So naming atoms and drawing structural, or naming molecules and drawing structural formulas takes a little bit of practice, but it's easier if you start with your electron dot diagram so you know how many bonds something can make. And remember, if something can only make 1 bond, it's going to be terminal. It's going to end up on the end of a chain.